Section 3.1a, exponential functions and their graphs. First problems here are just calculator problems. So go ahead and have your calculator out. Plug each one of these three into the calculator. First one, 1.085 raised to the third power. And throughout this chapter, as we've done all year long, round everything to 3 decimal positions unless if you're told to do otherwise in the problem, or it does not make sense to round to 3 decimal points because of the context of the problem, such as if something was dollars and cents, it would not make sense to carry it out to 3 decimal places. Let's look at B15 raised to the 5/7 power, and C2 raised to the negative pi power is that. So record each of those 3 solutions. First one, letter A to 3 decimal points is 1.277. Letter B to 3 decimal positions, 6.919. And letter C is 0.113. Majority of this section is going to be graphing exponential functions. So number 2 here, part A, graph, list all asymptotes and intercepts. Just like when we graphed rational functions, you must plot your asymptote lines as part of your graph for exponential functions. If you don't, you're not going to get full credit for your graphs. Again, the asymptote line is not part of the actual graph, but it allows the reader to look at your graph and know that that function is getting closer and closer and closer to that line and does not go on forever going up and away or down and away depending on how your graph looks. So here, beginning, first thing that you need to understand, if I look at this exponential here and I start picking some values of x, as I pick positive values of x, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, we go 2, 4, 8, 16, and so on, you can see that our y values would be getting large very rapidly as x increases. As x decreases, let's think about that. Starting with 0, 2 to the 0 power is 1. 2 to the negative first power is 1/2. 2 to the negative second is 1/4. 2 to the negative third is 1/8, and so on. We can see that this exponential by itself, and this is true of any exponential, this value is going to get closer and closer and closer to 0. And that's true of any exponential. Any exponential all by itself will get closer and closer and closer to 0. It will never get to 0, and that's the idea of the asymptote line. Okay, a line that a graph approaches but never touches. So in this case, we do have an asymptote line. We know that this exponential right here all by itself is getting closer and closer and closer to 0, which means that y is getting closer to 0. That's an example of then a horizontal asymptote. So we have a horizontal asymptote at y equals 0. Intercepts. Both x-intercept and y-intercept. Easiest one to find here is our y-intercept. Our y-intercept, we plug in 0 for x. 2 raised to the 0 power is 1. Our x-intercept, well, we should know if we have a horizontal asymptote at y equals 0, and what we just went through in the thought process was plugging in negative numbers for x. We know that y never will equal 0, so in this case, there is no x-intercept. Begin graphing what we have. We have our horizontal asymptote at 0. We have a y-intercept at 0, 1. And now let's pick a couple other values of x, make a table, and see what our graph looks like. Plug in 1 for x, we get out 2. Plug in 2 for x, we get out 4. So we have a point at 1, 2, at 2, 4. As we go to the left, if I put in -1, we get out 1/2. So we can clearly see our curve shape here is going to be approaching the asymptote line down here and then increase exponentially as we go to the right. Letter B, asymptote line. Any exponential all by itself gets closer and closer to 0. So if this whole thing is getting closer to 0, that means y, or g of x, is getting closer to 0. There's our asymptote. X-intercept, plug in 0 for y, 4 to the x power. Does 4 to the x power ever equal 0? No. Gets closer and closer to 0, but never gets there, so there is no x-intercept. Y-intercept, plug in 0 for x. Anything to the 0 power is 1. So once again, we have a horizontal asymptote at y equals 0. We have an y-intercept at 0, 1. Now let's pick a couple more values. I put 1 in for x. We're going to get out 4. So we have a point at 1, 4. Put in -1. We're going to get out 1/4. So we can see we have the same curve shape, but now it's increasing more rapidly as we go to the right because our base went from 2 to 4. Larger base increases exponentially quicker. Example 3, letter A. Horizontal asymptote. Again, any exponential all by itself gets closer and closer to 0. Y is getting closer to 0. X-intercept. Once again, there is none. Y-intercept. Again, we plug in 0. Anything to the 0 power is 1. Start graphing. Y equals 0. For your horizontal asymptote, your y-intercept is still at 0, 1. Pick a couple other values. I put in 1 for x, we get 2 to the negative first power. 2 to the -1 is 1/2. Put in -1, we are going to get out 2. Put in -2, and we're going to get out 4. So we can see we have the same graph as we had before, only it has been reflected over the y-axis. And if you remember when we talked about our transformations, the only thing that's different in this function than our first one in 2a was it went from 2 to the x power to 2 to the negative x power. When we add a negative just on x, remember that is when our graph is reflected over the y-axis. Letter B. Should have an idea of what this is going to look like before we even graph it. Same as what we had back here, 4 to the x power. Only difference now, we're adding a negative on x, so it should be that graph reflected over the y-axis. Let's find our information. Horizontal asymptote. Function all by itself gets closer and closer and closer to 0. So y equals 0 is our horizontal asymptote. X-intercept, there still is none. Y-intercept, put in 0 for x, and we're going to get out 1. Begin graphing. Y equals 0. X-intercept, 0, 1. Pick some other values. If I put in +1, I'm going to get out 1/4. Put in -1, we get 4 to the first power, which is 4. And there we can see that same graph that we talked about, but now reflected over the x-axis. Letter A, any exponential all by itself, that whole thing is getting closer and closer to 0. So we have a horizontal asymptote still at y equals 0. X-intercept, that is never going to equal 0. So again, there is no x-intercept. Y-intercept, plug in 0 for x. We put 0 in for x. We get 3 to the first power, which is 3. Begin our graph. Asymptote line. Intercept this time is shifted to 0, 3. Pick some values. If I put in 1 for x, I get 3 squared, which is 9. If I put in negative 1 for x, we're going to get out 3 to the 0 power, which is 1. If I put in negative 2 for x, we get 3 to the negative first, which is 1/3. Point at 1, 9, negative 1, 1, and negative 2, 1/3. Letter B, h of x equals 3 to the x minus 2. We know any exponential. This part right here is getting closer and closer and closer to 0. So that means y is getting closer to 0 minus 2, which is negative 2. There's our horizontal asymptote. Now we are going to have an x-intercept here. Let's come back to that in a second. Our y-intercept, plug in 0 for x, we get out 3 to the 0 power, which is 1. 1 minus 2 is negative 1. There's our y-intercept. X-intercept. We don't have a way of solving for this directly, so we're going to go to our calculator and actually find the x-intercept with the calculator. Let's graph what we have here first. Horizontal asymptote is at y equals negative 2. Y-intercept 0, negative 1. Let's pick a couple other values. If I put 1 in for x, 3 to the first power is 3. 3 minus 2 is 1. So we have a point at 1, 1. If I put in negative 1 for x, 3 to the negative first is 1/3. 1/3 minus 2 is negative 5/3. There's our graph. Let's identify where our x-intercept is by putting the graph into our calculator. Y equals 3 raised to the x power minus 2. There we can see our graph, and notice this is where you need to be careful when you use your calculator to verify these graphs. It looks like this line is horizontal from about negative 2 all the way out to the left. Remember, that's just because your calculator can't show it approaching an asymptote line because of the pixels. We can calculate here our 0, which is our x-intercept. Set the left bound, set the right bound, and we see that that's at about 0.631. Letter C, k of x equals negative 3 to the x power. Any exponential all by itself is getting closer and closer to 0, so our horizontal asymptote is back at y equals 0. X-intercept, that exponential is never going to be equal to 0, so there is none. Y-intercept, plug in 0 for x. We get 3 to the 0 power, which is 1. Apply the negative. We're at negative 1. Asymptote at y equals 0. Intercept 0, negative 1. Pick some values. Put 1 in for x. We get 3 to the first power is 3. Apply the negative. We have a point at 1, negative 3. Put in negative 1. 3 to the negative first is 1/3. Apply the negative. Negative 1/3. You can see now our graph has been reflected over the x-axis, which we know happens when we add a negative on the entire function. The second type of exponential we're going to talk about are exponentials involving the base e. Base e is what we use when we use natural logarithms on the calculator. What we have done previously would be common logarithms, and we'll talk more about the difference between those as we go throughout this chapter. 3e squared, e to the negative first, and e to the 0.12 times 4. Again, we're just going to go to the calculator, plug these in. Our e exponential, again, is associated with our natural log down here. So I hit second function and the natural log key. That's how we pull up our base e. Actually, before we do that, that was 3 times e raised to the second power. There's that. Next one was e to the negative first power. And the last one, e raised to the 0.12 times 4 power. So there's each of those 3 decimal approximations. Record each one of those. First one, 22.167. .368 and 1.616. Finally, the last example here, graphing in base E. Again, base E doesn't change anything we do with our graphs from what we've done with all the previous graphs we just looked at. It's just a different base, just as 2 and 4 were different bases, 3 and 4 were different bases, and so on. E is just another base. So when we're looking at this and we want to identify first our horizontal asymptote, we know that this exponential all by itself gets closer and closer and closer to 0. So y is getting closer to 2 times 0, which is 0. X-intercept, we know that exponential will never equal 0. So when we plug in 0 for y, that can't happen. There is none. Y-intercept, plug in 0 for x. When I plug in 0 for x, we know anything to the 0 power is 1. So y equals 2 times 1 because e to the 0 is 1. 2 times 1 is 2. So we have a y-intercept at 0, 2. Graph what we have, y-intercept. I'm sorry, asymptote line at y equals 0. Y-intercept is 0, 2. Now, just like when we had any others, we need to go and make an XY chart. Pick some values to plug in here. You're going to notice when you start plugging in values that your base E is relatively small, like our base 2. It's actually between 2 and 3. So when we plug in numbers here, we're going to want enough to be able to spread out our graph a little bit. So make sure you're picking large enough values. Let's pick 2 and 4 and go ahead and go to the calculator and plug each one of those in. See what we get out. So we have 2 times e to the 0.24 times 2 power. Remember, you can go second function, enter to pull up that last entry. Now let's just go up and change that 2 to a 4. And we get that. So 3.232, 5.223. Record those in your XY chart. And plot those points. 2, up a little more than 3, and 4, up a little more than 5. You can see from this that you can barely start seeing the curve beginning here. We know that this curve eventually has to approach this asymptote line. and pass through those points. Last one, g of x equals 1/2 e to the negative 0.58x. This exponential by itself is getting closer to 0. So our horizontal asymptote, y, is getting closer to 1/2 times 0, which is still 0. X-intercept, there still is going to be none. Y-intercept, put in 0 for x. When I put 0 in for x, e to the 0 power is 1, and 1 times 1/2 is 1/2. Asymptote line, y equals 0. Y-intercept, 0, 1/2. Pick some other values. Because this exponent is negative, I'm going to want to pick negative values of x so that we get positive values out. Again, pick a little bit larger values since our base e is a small number. Go ahead and plug this into your calculator. 1/2 times e to the negative 0.58 times 2 power. We need to, actually I need to put that in parentheses here. So let's pull that back up. Oops. Let's insert a parenthesis here in our exponent to make sure our calculator is following order of operations correctly. Using the wrong values here. We wanted to plug in negative values. So I don't think we actually needed the parentheses on this calculator. On some of them, if you don't have the exponent that pops up like that at the top, you are going to need the parentheses. Okay, that looks better there. And then we want to pull up that same entry and change the -2 to a -4. Record each of those two values in your chart. So my XY chart, I have 1.595 and 5.088. Plot those points. X is -2. We're up at about 1.5. X is -4. We're up just a little bit more than 5. And there's our graph.